Hello, brother. Let's say you have a derivative which you have to find of an integral. So something like this, wherein you have d by dx of integration of sine x dx, and you want to find the answer. So if I just see logically, integration of sine will give me minus cos, and when I take its derivative of cos is minus sine. So minus of minus sign will give me plus sign. So answer will be sin x, right? So if I realize that actually I could have just logically I could have done this way as well, that d by dx and integration, since integration is known as antiderivative, these both will get cancelled off and the answer has to be sin x. So without any calculation I can get the answer. But this is true only if it's the case of indefinite integration. So if you have something like this wherein you have a definite integral, let's say y is equal to definite integration, and then you have to find dy by dx. In this case, things are not that easy. You have to apply Leibniz rule. So what is Leibniz rule? Let's just check what is Leibniz rule. Leibniz rule states that if f is a function, continuous function on a particular interval, and the two limits, the upper and the lower limit, are differentiable functions of x whose value are again in the same interval, then Leibniz rule, the formula says that in the function you put the upper limit, you take the derivative of the upper limit, and then you subtract. In the function you put the lower limit, and then you take the derivative of the lower limit, right? So this is Leibniz rule. Let's apply this rule to this question. So I have the formula here, and let's apply it on this question. So this is the upper limit, this is the lower limit, this is the function f, and let's apply Leibniz rule. So this will be f of, so f in this case is log 1 upon log, so that is 1 upon log, and you will put upper limit, that is x cube, into derivative of upper limit. So derivative of upper limit is derivative of x cube, which is 3x square, minus f of the lower limit, so 1 upon log of the lower limit is x square, into derivative of x square, which is 2x. Now with power law I can write this as 3x square upon 3 log x, minus 2x upon 2 log x. This gets cancelled. So finally the answer is x square minus x upon log x, right? Let's check out one more question where we can use Leibniz rule. So let's say this is the question wherein it states that here again you have a definite integration a to x, where a is greater than 0, x is greater than 0, f of t upon t square dt is equal to 2 root x plus b, and b is a real constant. We have to find f of 4. So in this case again, if you want f of 4, that means this f should come out of the integration. So again what I'll do is I'll take derivative on both sides. Now if I take derivative on both sides, I'll get d by dx of this particular indefinite integration. So that is f of t upon t square dt, and here I'll take the derivative of this part, which is 2 root x plus b. Now let's apply Leibniz rule. So let's start the Leibniz rule. Now what we'll do is we'll put in the function the upper limit, so that is f of x upon x square, into derivative of upper limit is x, so derivative of x is 1, minus f of lower limit, that is f of a upon a square, derivative of lower limit, a is a constant, so derivative is 0, equal to 2 root x, derivative of root x is 1 upon 2 root x, plus b, which is 0, and this gets cancelled. So what we get is fx upon x square is equal to 1 upon root x. Now we need to find the value of f of 4, so I'll put f of 4, so instead of x I'll put 4, so I'll get f of 4 upon 4 square is equal to 1 upon root 4. So finally I'll get the answer as f of 4 is equal to, so this is 16 upon 2, the answer is 8, right? Let's apply it in one more question. So you'll find that even in questions wherein you have limits, Even in limits, you can use Leibniz rule, because in limits you have L'Hopital rule whenever there is 0 upon 0 or infinity upon infinity. So in this question, if you check, see the question is limit x tending towards a 1 upon x square minus a square integration of a to x sine of t square dt, and you have to find this answer. A is greater than 0. So if I write this question this way, I can write this as limit x tending towards a, this is a to x sine of t square dt, and the limit goes here as well, so that is limit x tending towards a x square minus a square. Now if you check, if you put x as a, so a to a, so this will be 0, and even this will be 0, a square minus a square, so this is actually 0 by 0. So you can apply L'Hopital. Now L'Hopital, what L'Hopital states is, you take the derivative of the numerator, you take the derivative of the denominator, and then again you put the limit. So let's apply that. So if I apply L'Hopital in the numerator, it's definite integration. So I can apply Leibniz rule. Leibniz rule states that in the function you put the upper limit, so sine of x square into derivative of the upper limit, which is 1, minus in the function you put the lower limit, so that is sine of a square, derivative of a, which is constant, is 0, upon derivative denominator x square derivative is 2x, a square derivative is 0. So now you put x as a, so you get sine of a square upon 2a. So this is the answer. So hope you like this particular video, and this Leibniz rule is very famous, can be used in JEE mains, especially MHT CET as well, and also examinations such as EMSAT. So till next video, please take care of yourselves, and if you like the video, please subscribe to the channel and wait for more such videos. Take care. Bye bye.